Hi everyone, and welcome to this Neo4j webinar on identity and access management. My name is Alessandro Svensson, and I work with solutions at Neo Technology. And together with me today, I have Ryan Boyd from our DevRel team, as Corey mentioned, and he is going to provide us with some Neo4j and Cypher demonstrations around IAM later on. So thank you for joining us. This is today's agenda. We have a lot to cover today, and we're going to start off with a short intro to graph thinking and move on to defining identity and access management, how IAM is evolving, the use of graph databases in IAM. We're going to show you some case studies and some examples of adoption of Neo4j. Ryan is going to show you a couple of demos, and then we'll wrap up and leave some time for questions. So, okay, let's begin with talking a little bit about graphs and graph thinking. Some of you are probably familiar with this, but it doesn't hurt to get into the world of graph thinking a little bit before we get into IAM. And I think to understand what graphs are and where they come from, we have to consider the way databases have evolved in order to handle large networks of connected data. And while the traditional relational databases are great for storing data that is heavily structured, that's just not how data looks anymore. What we see here is a huge explosions of connectivity and value being created within huge networks of connected data. And another way to put that is to say that data structured as tables, columns, and rows is evolving to be stored and modeled in a way that the data is relating to itself. And this is what modeling data as a graph is. So, simply put, a graph is connected data, which essentially means data points, or nodes as we call it, that have relationships with other data points. And this could be a person that has a checking account with a bank. It could also be a hotel that has rooms which have availability, or it could be people who know other people, which is what we call a social graph. And this, of course, could be expanded to people who know other people who perhaps study together, who work at the same place, who study with other people who work somewhere else, etc. And this is exactly how data appears in Neo4j. And one of the benefits with this model is that it's extremely intuitive to understand, and it's very easy to model. But the interesting thing is what happens when you start adding more and more relationships to these graphs, and these things start to take off at scale. And forming an extremely powerful foundation from which you can derive value through analysis, perform real-time queries, and to build extremely powerful applications and algorithms. So that covers kind of like the basic of graphs and how you can think about graphs. But today we're going to talk about graphs in identity and access management. And IAM is traditionally defined as the process of assuring who gets access to what, at the right time, and for the right reason. And there are two major themes that affect IAM, and that is how you define the identity, and the other one is your perspective of the structure of organizations. And the penalties we see within traditional identity and access management systems are that they firstly tend to have a very static and limited idea of what identity is. And secondly, that there's an underlying assumption that organizations are strictly hierarchical. And this have affected how we used to approach access management in the past. Ian Glaser-Gartner, I think, he made a very elegant and simple explanation of how access management processes works in a blog post a couple of years ago. And I'd like to recap some of his major points because it says a lot about the legacy that exists when you talk about IAM. And traditionally, what happens is that when an individual is hired and put in an HR system, an IAM process gives that individual access to different resources and systems within an enterprise. that's what happened when someone is added to the organization. Similarly, we see what happens when someone changes jobs. In this particular scenario, someone moves from a customer support function to inside the sales. And that too signals the IAM process to do something by way of HR, in this case, remove someone from the knowledge base and give them access to CRM. And lastly, when someone leaves the organization, and that signals the IAM processes to remove that individual from all access. And Ian Glaser talks about how these are the three major traditional life cycle triggers within IAM. And the fact is that it works. It definitely fits a purpose, but it's also a very linear process that doesn't really mirror all the complexities of an enterprise in a digitized world. So there's a lot of things happening in the world of IAM, and we like to go through some of what we feel are the most important ones. And first, identity is getting increasingly complex. Second, the view of a world that is strictly hierarchical is being revised. And thirdly, what we want to talk about is that access management is more and more about connections and the relationships between users, partners, customers, things, and different touch points within organizations and ecosystems. So let's talk about the emergent complexity of identity. The fact is, in a digitized world, everything has an identity. When you think about digital identity, you often think about passwords and usernames, or at least some characteristics that has to do with your person. While that is, of course, accurate, it's also a somewhat limited view of what identity can be. Identity is often a collection of attributes. So a person's identity will differ depending on the role that the person has at the moment. For example, an identity can be a personal identity. At the same time, you might have a consumer identity, a customer identity, a partner identity if you're an enterprise supplier or a contractor, or simply a citizen identity, all of which collects a richness of attributes within themselves. Similarly, things have identity, also have identity, and here we talk about identity in terms of serial number and unique IDs, for example. So your phone will have an identity, your washing machine has an identity, and so on. The interesting thing is when you start to collecting and connecting these identities in networks, things have links to humans, and humans will have links to things, and so on. And all of this will, of course, be reflected in your application and services. And in that regard, identities are becoming almost the heart of our applications and services, not only from a personalized user experience point of view, but also linking your devices and apps to the right identities also becomes a matter of security and a matter of mitigating vulnerability. So identity is becoming extremely complex, and this new paradigm is, of course, changing how we would approach identity and access management. So let's see what's happening in the world of IAM. Access management used to be a pretty straightforward, and the IAM processes used to represent a pretty simplistic world of what access meant. So people accessed applications hosted on-premise through specific devices, and in a scenario like this, access management isn't really that complicated. Today, this is simply not a reality anymore. As we discussed previously, people take on several different roles, and even if you don't think about it, they will be connected and require secure access to millions of things. They will use different types of devices with different types of dependencies. And all of these individuals and roles will expect to access and use services and applications in a very granular and personalized way. So all of this is, of course, highly interconnected. And all these relationships have tremendous value, and your IAM process has an enormously important role to play, and from many different perspectives. And I think this picture shows you that what's emerging are the incredibly rich data relationships between people and things, and the different personas of people and things. And the job of IAM is going to be to use these relationships to manage who gets access to what. And whether it's about accessing data coming from an IoT device, or whether it's about access to control device remotely, or whether the device should have access to a cloud API, or whether a person should share information with another person, etc. In all these different scenarios, you can provide a richer experience by leveraging these relationships between all these people and things and be able to play out different scenarios and ask those questions in real time. And this is what the world looks like, and it's scaling rapidly. We're going to reach an environment where we'll see connected devices and people by the billions. So just imagine how many data relationships that have to be in place to make sense of all this, knowing that the devices are being connected. And if they're not properly secured, this is going to be a huge risk from a privacy and cybersecurity point of view. So data relationships are going to play a key part of the future when we build IAM systems and when managing digital identity. And an enterprise that doesn't appreciate and understand the full complexity of who the customers are in an environment like this will probably start faltering quite quickly. So I think it's a very exciting time for IAM, and especially for graph databases within IAM. I think how we securely manage these billions of relationships between users and things, and collaborators, employees, customers, and consumers is going to be one of the epic undertakings of the future. So another aspect that we wanted to highlight is the legacy that many IAM systems and processes face, which is that the technology that has been used traditionally within IAM is based on the underlying assumption that everything is hierarchical. And the way we handle identity has to become more intelligent, more active, and more adaptive. And these static structures and hierarchies simply don't do the trick anymore. So the rigid hierarchy that we normally would associate with organizations and companies, that's just not an accurate view of how the world works, given the increasingly collaborative nature of business and organizations. So the interactions and relationships that take place within a business are far more complicated than this. The fact is that reality looks more like a graph, and graphs are the best way of representing data relationships. It's impossible to represent the richness of semantics, how different roles interrelate, and how their access ought to be managed using a rigid hierarchy. So this is one of the reasons why traditional IAM systems that don't model relationships all that well will suffer. There's also a purely technical aspect of this, and that is that the strict hierarchy represents, from a technical point of view, basically what you can achieve with classic parent-child type of relationships, which kind of force you to build hierarchies in the shape of tree structures. And sure, yes, from an access management point of view, this will be an ideal world. The problem, again, is that the real world doesn't look like this. The real world is not properly represented by a rigid structure. It's dynamic, it's more interconnected, and it's constantly evolving, which means that if you want to force a structure that is not a tree into a tree structure, you're going to build systems that is very vulnerable. And that's another reason why a shift to graphs within identity and access management is so important, because graphs have the ability to represent, model, and store data relationships in a way that is closer to reality, and then query this data in real time. So let's look at how Neo4j is used in IAM. We see two major trends in which Neo4j is being adopted. And the first is to simply build your IAM system as a graph from scratch. And the second is to augment your existing IAM with Neo4j. And let's look at a couple of case studies that would explain this. So the first one is Telenor, and Telenor is an example of a company that has built an entire identity and access management repository using Neo4j. And Telenor is a telecommunications provider. It's the number one telecom company in the Nordic countries, and I think it's number 10 in the world. So this is a huge company with thousands of employees and millions of customers. And what Telenor did is that they have built an access management tool around Neo4j. And as a telco provider, you have millions of customers with different subscriptions, configurations, data plans, devices, etc. And in that regard, it's a pretty complicated business. And most of these customers are enterprises themselves, where Telenor provides their employees with phones and subscription plans. And when Telenor makes a deal with an enterprise, like, for example, the Walt Disney Company, what happens is that Telenor authorizes access to the Telenor system to certain administrators at these different companies. So when you need a phone as an employee, you don't have to deal with Telenor directly. You deal with your own local help desk or IT department. And enterprises themselves, as we learned, are very complex. There are subdivisions, multiple business units, different groups and projects, different employee types, and so on. And these administrators are often only granted permission to administrate parts of these organizations. And as Telenor, if you want a 360 view of an enterprise customer, in order to provide efficient customer support, but also to enjoy upsell and cross-sell opportunities, this becomes almost impossible to achieve without. And the fact is that the system they replaced was a system based on relational database structure with massive joins across millions of plans, customers, and admins. So, and it required almost 9 hours every night just for the batch process, and it produced very stale data. So it wasn't really up to date with their challenges. So now with Neo4j, they can enjoy real-time login response times using the most recent data, which significantly has led to mitigated customer retention risk, along with a bunch of other benefits. So that's an example of a use case and its benefits where a company has built something around Neo4j from scratch. Another case study that I want to mention, I want to show you is FordRock, who are doing very exciting stuff with graphs within IAM. And this is about how you can augment existing system using graphs in Neo4j. And let's recap a little bit. We talked about some of the challenges with existing IAM, and one of them is that identity data will often be separated into different silos. So you would have your consumer data, your partner data, your customer data, your employment data, your device data, etc., in separate systems. And this data is often, as we mentioned before, will often be very static in its nature and its structure. And lastly, what we also discussed is what we often see is that technical legacy is based on a strictly hierarchical representation of an organization, which is inaccurate. So what FordRock is doing is that they use all different kinds of data sources that exist within an organization and bring all these different data pieces and reconcile them and make sense of them in what they call a relationship layer. And then pull that enriched data together so you can provision new accounts, new entitlements, different attributes, pulling that data back into your traditional enterprise identity management systems. And what they do is that they take different key pieces of information, not all the data, but the pieces that you need, and then weave them together, weave together relationships between those, and that's where the graphs comes in, and that's where what they built with Neo4j. So that they get this sort of new sort of cross-vertical or cross-silo set of relationships that provide a whole new set of insights on top of existing systems. So you start to think about this in terms of your customer scenario, where you got a large enterprise of different lines of business, users registered with different types of account names across those lines. And you want to have, as Telenor did, a 360 view of what that customer is and what kind of experience they had when they bought a product or subscribed to an online service, for example. When they visited your physical store, what kind of experience they've had when they interacted with your customer support, etc. And being able to take some of those key pieces of information and pull them up into a relationship layer and then extract the value about who the customer is what they and what they're looking for and what they're experiencing. So you can also think about this in an enterprise scenario where you have internal employees and contractors who are responsible for your day-to-day and to keep your customer-facing processes up and running efficiently. And the relationship layer here enables you to understand risk profiles better to mitigate insider threats, whether intentional or unintentional. So the idea here is when we live in a world where enriched, accurate identity is becoming increasingly important when it comes to access, the point is that all the relationships that you can build between these entities will add this whole new level of value across your organization. And from an architect point of view, ForgeRock uses Neo4j in a couple of different ways, and in this particular scenario, they use a product called OpenIDM, and OpenIDM has a tool that extracts key data from different data sources, as in the previous example, and reconcile this in what they call the relationship layer, which is powered by Neo4j. And the way this works is that they've taken their scripted REST connector capability and they've built a connector that talks to Neo4j, and then they use that connector along with the rules and mappings that goes along with it to inject a series of nodes that are people-based and a series of nodes that are device-based, and then build relationships between them in Neo4j before they pull it back into the traditional IAM. So that's an example of a way of augmenting existing system with the use of graphs. I also want to show you another way they use Neo4j within their systems, which is called OpenAM, which is an access management tool. And this is a small sketch from a demo that ForgeRock presented at Graph Connect last year, but I think it does a good job explaining the basic idea. So what OpenAM does is that it restricts access and forces authentication when accessing different services. So OpenIAM has the authorization plugin that talks with the Neo4j database. At the same time, OpenAM product is protecting the actual service that this particular individual wants to access. So the OpenAM agent sits there to intercept all the requests to make sure that the user has the appropriate authentication. And the idea here is, of course, to restrict access into services. And the reason why they use a graph database is the complexity around identity and access for all the reasons we discussed previously. And this is another example of how Neo4j would fit in an architecture to augment existing systems. If you want to learn more about this particular case study, I really encourage you to check out ForgeRock's presentation from Graph Connect in San Francisco last year. And this is available on the Neo4j YouTube channel and at graphconnect.com. It's very cool. I encourage you to check it out. So with that, I'm going to hand over to Ryan, who's going to walk you through some different AAM scenarios in Neo4j. And afterwards, please hang around for questions, and we'll try to get us to as many of them as possible. So over to you, Ryan.
Thank you, Alessandro. I want to give you guys an overview of what an IAM solution may look like in Neo4j. And to start off with, I'm going to talk about the different types of IAM solutions, just recapping a little bit of what Alessandro was talking about, but more in terms of implementation than theory. So there's two, actually three styles of implementation, which I'm going to talk about here. And the first one is using Neo4j as an identity and access management repository. This means that you're creating a graph in Neo4j to store all the identity and access information. It's the system of record for this information. In that case, you're modeling your identity data in Neo4j, you're maintaining all of your relationships as a graph in Neo4j, and then you're doing authentication and authorization decisions using those identities and relationships. The second one, though, is something that may be a good first step for many organizations, and that is integrating Neo4j to supplement the authorization decision process. This means that you're modeling your authorization data as a graph in Neo4j, and you're making authentication and authorization decisions that use the identities, relationships, and activities stored in Neo4j. So it's not your system of record for all these identities or for the relationships, but you are using it to support your decisions. So in the case here of this graph that you're seeing at the bottom left from Noli, this graph is a graph representing a user in blue there named Dave. And the user logged in through their Safari-based browser at a particular IP address during a specific time And this graph is storing the information about that user's login. And then as another user logs in, so in this case, I'll pronounce it Heidi, logs in, if they're logging in from that same client during the same period of time, then we can consider this computer or this client to be a public client. We have multiple users logging in during the same period of time from the same IP address with the same browser. It's likely not a private user's machine. And that gives you information that you can then use to make further authorization decisions. You can use that to decide, hey, public machines are a little bit riskier. Maybe we're going to reprompt for the user's password in our single sign-on system a little bit more often because it is a public machine, or maybe we're going to require a one-time password because we consider it a public machine, and things like that. So the graph really helps you understand both the success and failure scenarios of your user authentication and authorization decisions. Then the other type that we're going to talk about, and this is what I'm going to demo mostly, is about using Neo4j and graphs to audit your current IAM solution. So importing your data into Neo4j, both identity and access data into Neo4j, modeling it, visualizing it as a graph, and then using those visualizations, exploring the graph, and developing queries that detect patterns, such as sibling relationships, which could lead to vulnerabilities in your security infrastructure. And we're going to see exactly how this works here shortly. But I do want to say, we have a customer in the Fortune 100 category that is using Neo4j just for this scenario. So they have hundreds of thousands of employees and partners in their organization, and they've discovered that as their Active Directory group structure has grown over time, it's become quite complex. And due to those complexities, people have taken different patterns in the way that they use the groups and the organization hierarchy in Active Directory. And some of those patterns had left them open to vulnerabilities. And so they decided to use Neo4j to import all their data regularly from Active Directory into Neo4j, and then run regular queries on this to determine whether those patterns exist in their Active Directory, and then hunt them down and remove those vulnerabilities from their Active Directory group structure. So now, like Alessandro said, I'm going to jump over to Neo4j and show you an actual demo. And in Neo4j here, let me start by showing you a very basic version of the graph I have. You can see on the left-hand side, this is the Neo4j browser. It's the developer tool that comes along with Neo4j, and it is used to explore, as a developer, your data in Neo4j. There are a lot of other tools that are available if you're trying to offer end users BI or visualization, things like Linkurious, etc. But in this case, we're using the browser as a developer, and we're seeing here are the different labels that are in our graph, and here are the relationship types. So the labels are sort of like types or classes as a developer. They describe the objects. You can actually have multiple labels assigned to any given node. So if I look here at my departments, so these are the departments in the organization, so sales, engineering, manufacturing, marketing. These departments actually do have multiple labels here. So if I look at engineering, engineering is a department, but it also is a group, and it's also an identifier used for authorization purposes. And so we have departments, we have regions. The only relationships we have here are grants access to and is member of, and we're going to dive into what those mean here. But first, I want to show you a little bit more information about the data that is in here, just to set us all on the same page. We have a number of different groups in our database here. And these are groups that can be used for authorization decisions. They're based off of kind of dynamic ad hoc groups in addition to the organizational hierarchy. So you can see here, we have a large company. I think we have 48,000 or so employees in this company, and their largest segment is their manufacturing group. And of the employees in the company, we have about 16,000 in LATAM, about 16,000 in APAC, and we have these various other groups here that you can see within the organization. And we can look down and we can explore based off of the departments and how many people are in the specific departments. So we're a manufacturing-driven organization with the next largest department being engineering and a few smaller in sales. And so this is showing you how you can get tabular results in Neo4j, very similar to what you would get from a relational database, but taking advantage of the relationships that are presented in the graph and using what's called index-free adjacency to optimize for performance there. You can look up that term, but that's kind of how we achieve the performance of looking at multiple levels in the database. So that's a little overview here, and then I'm going to go more explicit looking at just the departments and the regions. So it looks like all of our manufacturing is split between LATAM and APAC. We have engineering in North America and Europe, and then sales, finance, and marketing are spread throughout the world. So now let's look at resources. So these are our resources which we use our groups and usernames here to make authorization decisions for. So in this case here, I've only put one resource in the database, and that's the payroll server. And if I double click on the payroll server, we can see that the payroll server has two relationships off of it. And those relationships off of it are called grant access to. And we're granting access to the payroll IT admins, which is a pretty simple group with a number of users in our company as payroll IT admins. And we're also granting access to our infrastructure group to have access to the payroll server. And you can see here the nodes are fairly simple. But we do have some properties here. So I'm looking at an individual user, and we can see the user's gender, last name, first name, and their username. Username is a unique constraint here. And then we have properties on some of our relationships as well. So the level of access that is granted in this case is the super user level of access. So that's a dynamic property that I've added to my graph when I created the relationship grants access to indicate the level of access that person has. So that's pretty simple here. We have our payroll server, our IT admins for payroll, as well as the infrastructure group, both have access to that. Now, let's look at our infrastructure access group. And we can see here that we have this user, Thomas Formica, and Thomas Formica has access to infrastructure and thus has access to the payroll server. So I have a nifty query here that looks to say, does Thomas have access to the payroll server? And I'll explain some of these queries, but not others as we go along here, but you can ask questions in the Q&A. But in this case, I'm trying to say, in all the groups underneath payroll server, is Thomas granted access? And we see, yes, Thomas has access. And, we have his first name, last name, and username. So Thomas would have access to the payroll server right now. And we look at it and we think, okay, he has access to the payroll server because he's a member of this infrastructure access group. So let's do something here. Let's go over and we're going to delete Thomas from the infrastructure access group. And I'm going to execute that. And we're going to see deleted one relationship. And then if we go back here and run the query again to see the graph, I'm going to click on this query and click the play button to run it again. And we're going to see the payroll server. I'm going to double click on this and we're going to see the infrastructure access group. And then I'm going to double click on the infrastructure access group and see who's members of that. And you no longer see Thomas as member of the infrastructure access group. So we're going to think, hey, Thomas no longer has access to the payroll server and we're going to move on in life. Only we found out that Thomas continues to log in to the payroll server. And if we run this query, we can see Thomas still has access. And now you wonder, why does Thomas have access? Well, Thomas has access to the payroll server, and a lot of other users also have access to the payroll server. So this is going to return a list, but I'm going to instead want to return a count of our users. And we can see here we have 9,783 users who have access to the payroll server. Now, that's pretty scary. And we could keep on exploring for Thomas individually why he still has access. But we might want to go back here and see, well, what is this group structure like? And the group structure, I'm going to copy a query from over here. The group structure in here actually, whoops, let me add Thomas back to the infrastructure access group and show this to you after we do that. Sorry, GoToMeeting is slowing down my computer here a little bit, so getting a cursor that is a little jagged, but we're going to run this query and we're going to see here we have a really messy group structure. So we have a really messy group structure because Thomas is in this infrastructure group, and that's the one that we thought we could delete him from to remove his access. But it turns out Thomas is also in the engineering group. And the docs team here, the docs team said, hey, we want all of engineering to have access to our documentation because there is a new release pending. So they added the engineering team to the docs team, thinking that that didn't have much of an effect. Well, it turns out the inheritance hierarchy of this Active Directory implementation in these groups actually had the docs teams giving access or getting access to all of the infrastructure. And then because the docs team added engineering, everyone in engineering had access to the infrastructure as well. And that's just the really scary type of decision that happens in a regular basis in some large organizations. So you basically want to be able to run queries like this to see where are there sibling relationships between the groups and users in your Active Directory and remove this rat's nest. So let's start to clean it up. We're going to delete engineering from our having access to the docs team. And then after we delete engineering from having access to the doc team, we'll say, does Thomas have access to the payroll server? And we can see that Thomas still does. We're going to re-delete Thomas's ability to be directly in the infrastructure group. Delete Thomas from infrastructure group. And we're going to notice, though, that even after we delete this, Thomas still has access. Our access query here, our test query says Thomas still has access. But there's one other thing overall that we can see here in our relationships, and that is that infrastructure access grants access to not only the docs team, which we fixed that area, but to the product widget team. And the product widget team has a bunch of members in it, and then these temporary helpers. So we don't see Thomas in these bunch of members, but in temporary helpers, Thomas is actually in this group. So there's, in this case, like we're trying to remove access for Thomas to the payroll server, and we're figuring out that he actually has access granted in numerous different ways. We've cleaned up some of it by removing the Eng team's membership in the docs group. And now we just need to clean up the last of it, which is removing Thomas from the widget temp helpers group. Actually, that's adding it. Delete Thomas from widget temp helpers. And that should delete Thomas from that. And now we're going to say, does Thomas have access to the payroll server? And our answer is no. Thomas was not returned. And now we can say which users have access to the payroll server. And instead of almost 10,000 users in all of our engineering group, plus the people that are supposed to, we only have 14 rows. So in this case, I showed you how you can write some queries that do auditing of your Active Directory implementation using a graph. And then I actually did some of the cleanup here. And that cleanup I did in the graph database. And that would be if you're using the graph for your actual authorization decisions. But if you were using your Active Directory for the authorization decisions, you would do that cleanup directly in Active Directory. Let me just show you one of these example queries. And that is the does Thomas have access to the payroll server? And this shows you the awesome power of graphs. So here we can see we're looking for the resource with a name of payroll server using a JavaScript-like syntax or JSON-like syntax here. And we're saying the payroll server grants access to, and then finding everything that the payroll server grants access to with a arbitrary number of is member of relationships, basically going throughout the whole graph and following those is member of relationships to find if Thomas is anywhere in the graph having access to the payroll server. So that's kind of our test query if we're just using Neo4j for auditing, or our actual authorization query if we're using Neo4j to make our authorization decisions. So that just gives you an example of one type of vulnerability that putting your data into a graph can help discover, as well as gives you an example of how you can make authorization decisions using the graph. This is simplified a little bit. So we might have a inherit property, for instance, that we restrict the group hierarchy to only look at the groups when the inherit property is true and things like that. But it still gives you an idea of the real types of challenges that folks are facing in the IAM world today in making sure that their infrastructure is secure. So now I'm going to turn it back over to Alessandro to do a quick wrap up, and then we'll have hopefully about 10 minutes for your questions.
Thank you very much, Ryan. Yeah, I'm just going to give you a quick wrap up and summing up, and we'd also like to give you an overview of the adoption of Neo4j and what type of companies that use Neo4j. And the fact is that we have a very solid adoption from everything from government data operations to institutions like the World Economic Forum, ICIJ, and of course a number of commercial clients in the Fortune 100s like Walmart, eBay, LinkedIn, Cisco, that they use Neo for a variety of use cases. And we can say that Neo4j is the most popular graph database around. So we really do have a privileged view on many use cases and the usage of graph databases. And Neo4j is used in verticals as diverse as software, financial services, retail, media, social networks, of course, telcos, healthcare, and a bunch of different other verticals and use cases. And this is the latest DB engine ranking of graph database, and I think it really shows our popularity. We've been placed at #1 for a long time, and this is the latest ranking from September in 2016. So graphs really are everywhere, and as we like to put it, we're moving towards graph inevitability. And the analyst seems to agree with us, and Gartner talks about graphs being the single most effective competitive differentiator for data-driven operations today. And they predict that by the end of 2018, 70% of leading organizations will have at least one or more pilots or proof of concepts on their way. And Forrester goes so far as to say that 25% of enterprises will be using graph databases by the next year even. And given the adoption rate that we see, we really agree. So finally, I also want to give you a shout out for some valuable resources for those of you who want to learn more. If you're a developer, I strongly urge you to visit our developers page. If you're interested in case studies and solutions, there's a lot of interesting use cases and case studies at our solutions webpage. And if you want to learn more about the product in Neo4j, please visit our product page. And lastly, before we move into questions, if you're in the Bay Area around October 13, don't forget to register for Graph Connect, which is our yearly event in San Francisco. And there you can sign up for training, listen to customers sharing their graph projects, such as the examples I showed you before. You meet our Neo engineers and our senior staff. It's a lot of fun. I strongly recommend it if you're in town. Just visit graphconnect.com for more information on that. And with that, I want to say thank you for participating in this webinar. Thank you, Ryan, for demonstrating a bit of Cypher and Neo4j for us. I hope this was useful, and please reach out to us if you have any questions, and I hope to see you again soon.